Thank you all for coming tonight. Thank you, Tom, for being here. Tom is our speaker tonight, the Watershed Speaker Series, talking about restoration projects in the Madison. Tom has been in Montana since 1984, so almost 40 years now. Wow, a long time. So he knows this place front and back. And he is a principal ecologist at Geum Consulting. He is an ecologist focusing on floodplains, riparian areas, and wetlands. As a project manager, Tom helps guide large long-term restoration projects by working with interdisciplinary teams to develop strategic plans, master plans, implementation plans, mitigation frameworks, or whatever is required for each program. Current projects include the Upper Clark Fork River remediation and restoration, Kootenai River habitat restoration, and supporting the CSKT's implementation of their water compact. Tom spends his free time in the backcountry, accessible from the Bitterroot Valley, on mountain bikes, skis, or on foot. He has never appeared in a photo while holding a fish. So thank you, Tom Parker, for being here, and take it away.
All right, thanks, Casey. Okay, so back in 2017, the Madison River Foundation contacted me about doing a master plan for riparian restoration along the river in the reach between Reynolds Pass Bridge and Barney Bridge. So I think it was March 2017, I came down and met with Liz Davis, who was the executive director at the time. Sonny from the Conservation District was here, and then Dave Moser was the Fish, Wildlife, and Parks guy. So it was just myself and the three of them, and we kind of scoped out what a riparian restoration master plan would look like. So that's where it all started. In 2017, I floated the river from Reynolds Pass Bridge down to Barney Bridge, just to kind of get an idea of what was happening with the riparian communities and the river habitat through that reach. So I'll talk a little bit about how we're thinking about restoration along Madison, some of the things that I saw when I did that float, and then some of the projects that came out of that effort. So when we think about restoration planning, it includes river management, but it's also about habitat restoration. And then we think about how we're going to measure our progress and toward whatever goals we set. I'll talk about some of these things, limiting factors being, what's wrong with the river system that we can actually do something about. Some of the strategies, techniques, and project opportunities that we've developed. So when we thought about the vision for the river, and you'll see that there are question marks after some of these vision items, and that's because this is kind of always an ongoing conversation. Whoever lives in the community, whoever works along the river, whoever understands the river may have different ideas of what the river should be. But these are some of the things that I've heard over the years from that initial meeting back in 2017. Recognizing that there's a lack of trees and shrubs along that reach of the Madison River, especially from Palisades down, there's really not much there, which means that there isn't a lot of shade and cover for fish. There may be opportunities to separate agriculture from the natural riparian habitat along the river. And recently, we've started talking about the opportunities to restore side channels for spawning and rearing habitat, especially in that reach below Lyons, between Lyons and Barney Bridge, where there isn't a lot of spawning habitat along the river. Maybe doing what we can to restore a more natural hydrograph and sediment transport processes. Northwest Energy and Fish, Wildlife, and Parks are doing some work of a flushing flow study looking at the potential for that. Reconnecting tributaries, which would mean getting flow back into tributaries. Balancing recreation with natural ecosystem structure and function. And then, of course, it's always a question that really depends on where you are in the communities and the culture. How far toward natural conditions can you get, given the way that we use the river and the land around it? So I mentioned limiting factors, things that we can actually do something about that are limiting the ability of the ecosystem to function as habitat. So we talk about reduced floodplain connectivity, In this system, we have some natural glacial terraces that confine the river, especially from Palisades down to just above Barney Bridge. I'll talk about the effect that that has on riparian habitat and fish habitat. Low sediment supply because of reduced tributary inputs and of course a dam. Browse from wildlife limits the ability of plants to grow. Competition from grasses in some of these places where willows and cottonwoods would normally establish can limit those. And because we don't have the plants, we don't have the seed sources to produce new plants. It's a high kind of windy valley, so there's some limitations from just the weather, exposure to cold, altered hydrology from the dam, the history of livestock grazing, trampling, browsing, recreational impacts, people walking along the bank fishing. Infrastructure is always the limitation of these systems. So when we do restoration planning, it's useful to generate this kind of a list because then it helps you understand, you know, if you're going to do a project, which of these could you target and reduce the effects of these limitations. This is a map that's actually sitting in the back. If anybody wants to take a closer look at it later. In 2018, the state of Montana flew LiDAR to get a very detailed topography of the valley. And they did that for a floodplain study to basically improve the detail in the floodplain mapping. So this was generated from that, but it shows things like the glacial terraces that come right up to the river, some of the alluvial fans that are famous in geology textbooks coming off Cedar Mountain and Fan Mountain there. And then the reach of the river that we're talking about coming through Reynolds Pass Bridge right about here, and then down to Barney Bridge above Ennis is the reach that we're focused on. It's always good to have kind of a big geomorphic picture of what's going on topographically. I threw this one in just to kind of compare, you know, how have things changed over time. Aerial photos from the 1940s. If you look along the river, you can see some of the darker patches that represent what was woody vegetation. So some of those were conifers, some of those were probably shrub communities, and you can see, like for example, at the delta mouth of this tributary, there used to be a lot of woody vegetation, and there just isn't now. And that's pretty common along rivers everywhere, you know, especially in the West, where people cut down trees for firewood, simple things like that. Ranchers clear willows so that there's more grass. You know, it happens along every river system, and then once the vegetation is removed, it's difficult for it to come back because of livestock grazing, browsed by deer, elk, pronghorns, moose. You guys have a lot of animals that like to eat plants in this valley. So I'll kind of take you along on my float of the river back in 2017. What I was looking for is just patterns in vegetation communities. So this is right below Reynolds Pass Bridge, kind of in that upper reach of the river. You can see the island has willows growing on it, but the bank next, you know, the river bank that's accessible by land has no willows growing on it. If you look very closely, there are some tiny little willows trying to grow there. What this is just that island is less accessible, so the deer and elk are not eating those willows, whereas they are eating the willows on the bank. So that's a pattern that you see. And on the island itself, you can see that gravel cobble substrate that's really pretty uncommon in this river. One of the few places where you actually have spawning substrate in this reach of the river is right along the edge of these islands. So that's a resource that the fish biologists recognize as being important. And it's also a place where willows and cottonwoods can grow because the animals just don't get out there as much.
Do you know if that island gets flooded in the spring?
It does, yeah. Some of the islands get overtopped in the spring.
And I would think that plays a big role in what grows there.
It does, and you know, the willows are really adapted to being overtopped and flooded. They can actually be scoured out by ice, and it just kind of stimulates their growth because they tend to grow rhizominously or underground roots will send out and then generate new stems. Looking at the plant community structure, if you float through the river, and you'll see this pretty much throughout the entire reach, not everywhere, but continuously it's present, you see these sedges at the edge of the river. And you know, that's important because that's actually rearing habitat for fish. And then you can see behind the sedges, there's willows, and this is still in the upper river. The willows are important. You know, the plants are primary production, supports the food web. Some of the insects that the fish eat have part of their life cycle is dependent on these willows on the banks. Down near the West Fork confluence area, you actually have some riparian spruce forest present. Then you can see the willows and the sedges are still there. So different parts of that plant community vertical structure. And this, I would think of this as, you know, probably some of the best riparian habitat that you have along rivers around that West Fork confluence. It almost looks pristine, like you might see in a more of a wilderness type setting. And then below Lyons, you can see the sedges and willows. It's in this case, it's more your upland conifer forest where the foothills come right down to the river's edge. But you know, the conifers are important whether it's riparian forest or upland forest because they are a source of wood for the river. As you float along the river, you'll probably see places where all of a sudden there's no willows and then there's willows. And there's often a fence line associated with that break. And what it represents is just different land management on different properties. You might be transitioning from a campground to a piece of BLM land that's not a campground, for example, in this case, or public land to private land or the other way around. But you know, as you float down the river, keep your eye open, you will see a lot of these fence line contrasts. And it really represents land management. And then, you know, land management, livestock, I think historically were probably a bigger influence on this river. In the last 20 years or so, at least the agencies, I think, have started managing livestock grazing a little bit differently to kind of take some of the pressure off the riverbanks. And you actually do see a response where there are some willows coming back in some areas. And kind of ironically, you see that where ranch land has been subdivided into residential properties, and the cows are just not there anymore. And you do see willows coming back along the riverbanks in some of those areas. Down by Varney Bridge, as the floodplain opens up, you can see decadent cottonwood stands. And there's not a lot of new cottonwood stands forming along the Madison River. And this used to be a really important and widespread component of this ecosystem. And I'll talk a little bit more about cottonwoods later and some of the ecology and how hydrology supports those. So then more food for thought, assuming that many of you float the river and pay attention to what you're seeing. This kind of goes from upstream to downstream. When you think about habitat, terrestrial habitat, there are three main things that kind of determine what kind of habitat that is, what type of plant communities. So the vegetation, the type of substrate soil, and then how much water there is. So, you know, if it's dry and you don't get a lot of rainfall and the soil is salty, you might have desert vegetation. If you have lots of water, well-drained soils, you might have a very lush willow stand. So when I'm trying to interpret a river system and understand why vegetation is growing where it is, I don't just look at the plants, I also look at what's going on with the geomorphology and how that's affecting hydrology. So in that upper river, right below Reynolds Pass Bridge from Quake Lake down pretty much, you see a lot of seeps and springs coming in. You know, and there's even beaver dams in some of those, or because beavers will build a dam any place where there's building materials, which is usually willows, and water flowing even just a little bit. You see the sediment deposited islands in the river channel, so that's a geomorphic piece that supports vegetation. Willows and cottonwoods like to grow on gravel and sand and cobbles. Tributary confluences tend to be where you have your cottonwood forests, the West Fork Madison confluence, Indian Creek Delta, and that reach above Barney Bridge all the way down to Ennis Lake has cottonwoods. Connected floodplain areas along the main river. I'll show you some pictures of these. Very narrow fringe of riparian vegetation along some of the other reaches that are confined by those glacial terraces. From Palisades down, you'll see just kind of a 3 to 4 foot wide band that used to support willows, and you can still see the skeletons of those willows along that reach in some places. Large floodplain springs like Odell Creek emerging in floodplain just upstream from Cameron. And then the big, where the floodplain widens out, where the glacial terraces kind of pull away from the river, above Barney Bridge, where you get into that, what used to be a big cottonwood gallery forest that's really not there anymore. So when I think about what's the potential to restore vegetation and habitat along this river, I kind of broke it into these categories. One is a willow fringe. There's that narrow band along the river, like you have below Palisades, that is only 3 or 4 feet wide, and that's probably all it ever was. You may have had some other shrubs like rabbit brush, sagebrush, maybe some chokecherries behind it, but you probably just had a very narrow band of riparian vegetation there. The willow complex is more two-dimensional. Instead of a line on a map, it's a polygon on a map. And that's where, mostly above Palisades, you'll see these on an aerial photo, they just look dark green, and they're patches that are pretty grassy for the most part, but probably used to support willows. This is a good example where same elevation, this island and this bar feature, but willows here, no willows there because of the land use. Cottonwood forest, like I said, you see that above Barney Bridge all the way down to Ennis Lake at the tributary confluences. Spruce forest is probably just restricted to around that West Fork Madison confluence with the Madison River. So just a little background on kind of what types of habitats we have out there, a little bit about how they relate to fish and aquatic habitat. So now I'll talk about some of the restoration projects that the foundation has been involved with, working with lots of partners, obviously, and myself working with Fish, Wildlife and Parks and Northwest Energy. So the $3 bridge project was completed in 2019. That one really focused on limiting recreational impacts, but also is kind of separating livestock from a recreation site. Story Ditch is a project that was designed in 2019, and I think the foundation is planning to actually build that project this fall. And that's at the Story Ditch boat launch just upstream from that. And then I'll talk a little bit about side channel restoration opportunities along the river, and then some of the flow management work that's happening with Northwest Energy that can be related to riparian vegetation. So $3 bridge, kind of in the upper river section. This is a view looking, I think we're on the $3 ranch property, looking upstream at the bridge. You can see there's the 2 parking areas, one on either side of the river. So this parking area here, there's basically a lot of people were just kind of walking down through the slope wetland directly to get to the river. And, because it was a slope wetland in that area, it has very mucky soils. So it doesn't take many people walking through there before a trail forms and then before kind of a mudslide forms. So one of the objectives of this project was to kind of protect that wetland from all that human foot traffic that was happening around it. And we did that by building a series of flank bridges. That's the blue line. These dashed black and white lines are actually wooden steps. These red polygons are fences where we just built fences tall enough to keep deer out, about 6 feet tall. And then these rectangles were additional fences with the goal of planting willows within those and kind of forming a corridor to further keep traffic focused on these trails. And then we built a jack-leg fence along the top there and added an educational sign so people knew why we did all this in the first place. So here's what the plank bridges look like. And you may ask, well, why did you put all that wood out there? Why didn't you just build a trail? And the reason is along this river, there's a lot of cultural artifacts. The Madison Valley and the Big Hole Valley were used by a lot of different tribes historically. So here you have Blackfeet tribe, Shoshone Bannock tribe, Confederated Salish and Puny tribes, all and some other tribes all use this area. So places like this, there's a lot of artifacts around. So instead of trying to figure out how to avoid those, Fish, Wildlife and Parks, who manages this site, just said, you can build trails, but you have to build them on top of the ground. No ground disturbing activities. And I'm sure you guys probably run into that with some of the projects you do. So that's why we did plank bridges here. Jack-leg fence, similar, just sits on top of the ground. Here's one of the exclosures, and what these exclosures did was, we noticed that there's lots of little willows growing in there, but they're getting browsed every year. So these fences are intended to protect them and allow them to grow up tall and just kind of fill in the gaps. This is one of the plank staircases that get you from the top to the bottom. And then that little exclosure there that we planted a lot of willows and dogwood and birch inside of, we called it a willow wall because the idea is that we would actually produce a wall of willows that would kind of keep people on that trail and from walking through that area. And here you can kind of see what that ground used to look like when people were just trampling through there. This photo was taken just after the project was completed. And within really a year, it was hard to see any of those effects. I haven't been down there in a couple of years, so crossing my fingers that that's still the case. And access through the fence to get in there. So that's what that project was, with some education. It's kind of explaining, taking the approach, recruiting people to basically help protect the river with this information about why we did this and where to walk, where not to walk, that sort of thing. So then, I think we did that project in 2019. 2019, we started working with the Bureau of Land Management. The Madison River Foundation had been partnering with BLM for a few years actually before this. And so Bureau of Land Management was developing an environmental assessment, which is a NEPA document that is necessary to do projects using federal money or with any kind of connection to the federal government. You hear people talk about environmental impact statements. Environmental assessment is kind of a short version of that type of thing. So the foundation actually worked with BLM to include a suite of different types of restoration projects within that EA so that that NEPA would already be done by the time we started wanting to do projects. So that's kind of the connection to BLM and why we were looking at projects on BLM land. So we spent a couple of days actually walking around with some of BLM's resource experts. They don't do a lot of river management. They're mostly focused on the grazing units. So the fact that we were interested in doing projects along the river was interesting to them, did not conflict with anything that they did, and they just were supportive of it. So we found a few different projects to work on. One of them was the Story Ditch boat launch site. So just upstream from Story Ditch, we noticed that this is a site that you look across the river, you can see all those willows. This side of the river, there's not a single willow. There's maybe a few, like every 20 feet along the bank, some scraggly willow or dead willow. So that we thought this would be a great site to demonstrate one of our restoration techniques that would restore willows along the riverbank. So this is that plan where the red lines are basically access routes that we would use. You need to show those on the plan. We included another exposure fence. You can see there's a stand of willows here. The idea of this was just to extend that willow stand this direction by protecting it from browse. And there were willows in here. And then the yellow lines along the bank are actually locations where we would do a bank treatment to get willows growing along the bank. So if you look at that leftmost yellow line, which is number 1, here's kind of zoomed in on that. The yellow dotted line represents the riverbank line. So below that on this figure is the Madison River flowing to the left. And then this blue zone is a floodplain bench, and the purple zone is a slope tie-in. So what this represents, if you look at this dashed line, that's kind of the design bank, but the solid line is the existing bank line. So the idea here is to excavate down about 2 feet, 1.5 to 2 feet to an elevation that matches the elevation where the willows are growing on the other side of the river, so that we can get willows growing there. And we think that if we do that, we will kind of leave behind some sand and gravel substrate, and then there's enough willow seed in the area that they'll probably colonize it themselves. In addition to that, though, we will install willow cuttings. So when you build these benches, you actually excavate a trench that goes down and back from the river. So when you put your willow cuttings in the trench, the bottom of the cuttings is below the base flow elevation of the river, so they're wet, and they need that moisture to be able to grow. So you put your cuttings in there, you put some dead brush in there, which helps protect them from browse, and then you backfill it to this elevation here, leaving it kind of rough so that willows can colonize from seed behind it on that elevation that we know supports willows. So it's a pretty simple treatment, one that we've done in other places. This is a picture of one that was under construction during this photo. I actually built this in February of 2022, which is a good time to build them because the willows are dormant. And you want to be using dormant plant material. And this is only kind of underway, but that would be backfilled. And then in the summertime, those willows leaf out, form roots, and you have an immediate vegetated bank with overhanging cover and shade, and essentially primary production for the food web. Talk a little bit about side channels. In case you got to join us on our side channel site visit last week. So one of the things that's really lacking in this reach of the Madison River is spawning habitat and rearing habitat for fish. The main channel is basically a big long riffle, from Lyons down to Varney Bridge, essentially. So when Northwest Energy and Fish, Wildlife and Parks undertook their flushing flow study, which they've been working on for a few years, the idea of that study was to intentionally pulse a flood flow through the river from releasing water from Hepburn Dam, and see if that would result in any changes in available spawning habitat in the river. The idea is that, a little bit bigger pulse could move some gravels and sands into places where it's not currently present in the river. Long story short, that they conducted that study, did some analyses, and realized that Madison River is it's either really big material or very fine material, and you just can't keep those gravels and sand in the river. They weren't able to move the needle enough with the flows to produce an effect of that type. However, the thought was you could do that if we reconnected some side channels. So we looked at a specific side channel, did some investigation, which included digging some holes with a backhoe to see what was underneath the fine sediments. And where you would actually dig down to create a side channel that's connected perennially throughout the season when fish would need to use it, which is pretty much all year, because we're looking at spawning and rearing habitat. What happened in all of these side channels, these used to be connected to the river. At some point after Hebgen Dam went in, there was probably a big pulse of fine sediment from some of that happened. So every single side channel along the river has, or most of them at least, has a pretty thick layer of very fine, kind of silty, sandy material. It's not spawning substrate. And it's also not at an elevation that supports perennial flow. So basically, most of the side channels along the river got filled in at some point. And you also see that along the banks. That bank in that previous project I showed you, Story Ditch, has about the same amount of fine sediments on top of the correct kind of gravel and cobble substrate that would support vegetation, would support spawning habitat. So we went into one of these side channels, dug a couple pits, and sure enough, right about at the elevation where you would build the bed of a side channel, there is suitable gravel cobble material. The biologists like the gravels kind of in the 10 to 30 centimeter or millimeter size range, and there was a pretty good amount of that material, in addition to bigger material that would resist being mobilized during the flows. So from 2 pits, which isn't a very big sample size, we will be increasing that by looking at other side channels. It sure seems like this is something that would be feasible along the river. And it would, I talked about LiDAR already, so we don't need to do that, but this is just kind of a concept of what it would look like. So here is a potential flow path of the side channel. The reason it's sinuous and not just straight is so that we could get enough additional length to reduce our slope to keep the energy below what would mobilize and move the gravels out of the side channel. So that results in about a 0.3% slope. If we ran a straight channel through there, it would be 0.4%, and that's a big difference. Doesn't sound like a big difference, but it actually is. This is existing ground from the LiDAR, so it kind of shows you how deep that layer of fine silt and sand is. And then this would be the elevation that we excavate down to the design side channel bed. And this is where we started to see the gravel and cobble. Everything above it was really fine sediment. So that's kind of the basic idea. And then we would line these side channels with similar bank treatments, lots of wood and willow cuttings, with the idea that we're creating shade, cover, rearing habitat for the fish. We haven't designed one of these yet, or we have a design for one, but we're just looking for a place to do it. So that's kind of where we're at with this project. And we expect to build one of these side channel projects in 2024. We being the Madison River Foundation, Fish, Wildlife and Parks, Northwest Energy, and whatever partner agency whose land we end up doing it on, which may be BLM, and some private landowners. So the last thing I'll talk about is ecological flows. And I just have a couple slides on this. So what this is showing, when we think about flows and what they mean in terms of ecological function, we often think in terms of exceedances. So if I say a flow is a 90% exceedance flow, what that means is that flow is exceeded 90% of the time. So that's a pretty low flow. So 90% exceedance is roughly base flow. Then if I talk about a 20% exceedance flow, it's a bigger flow than a 90% exceedance flow. And that flow is only exceeded for 20% of the time. So that range between 90%, 80%, and roughly 20% is what we think of kind of in the ecological world as flows that are kind of producing results in the ecosystem, whether it's moving gravels around, whether it's creating scour and deposition that will then be colonized by willows or cottonwoods. So that light blue color, you have the dark blue color, which is that 90% exceedance. The light blue color is that range between the 90% and the 20%. So that's kind of where things are going to happen. You're not going to get willows growing in the river, but you will see them growing kind of in these zones that get inundated by those flows that are exceeded, only 20% of the time. You get much above that, and it's too infrequent, maybe too dry. So I don't know if that explanation makes sense as to what this is. So to test this hypothesis, it's kind of a hypothesis. This was based on using some of the hydraulic model outputs from that sediment study that actually allowed us to calculate those exceedances and put them on the ground and put them on a map. We then take a look at what that looks like in terms of a hydrograph. And I thought, well, this is probably too many colors to show people on a slide. Then I thought, these guys can probably handle it. So what each of these different color lines represents is an annual hydrograph for a different year. So each year represents a different color. And what a hydrograph is, on the vertical axis, the y-axis is the river stage at Cameron. So that's actually the gauge height at the Cameron gauge. And then on the x-axis is time, January 1st, December 31st over at the other end. So that's 1 year worth of time. So it just shows you the variation in flows throughout the year. That's what a hydrograph is. When we think about riparian vegetation such as cottonwoods, this rectangle is a theoretical kind of space within this graph that we call the cottonwood recruitment box. And it represents a range of flows and a period of time. So what it is it's roughly that 90% exceedance to 20% exceedance. So it's it's between base flow and kind of your average annual peak flow. And the period of time between about mid-June and the end of July when cottonwoods are producing seed. So there's seed available. The other piece of this is you also have to have substrate available for those seeds to land on and for this hydrograph to support. So the idea here is if you have a year when the hydrograph is actually within this box, you have ideal conditions to create a new cottonwood community or willow community, because the cottonwood seeds are starting to fly around in the air. The water's up here, the seeds can land, and then as the river stage declines, the seeds can germinate and the roots can follow that water down. And cottonwood roots and willow roots can grow about 1 inch per day. So yeah, so it's kind of cool. And the plants are adapted to this hydrograph. Some fish are too, in terms of Kootenai River white sturgeon is adapted to the same hydrologic cycle in terms of when they time their spawn, and when the correct substrate is being moved around in the river. So it's kind of neat, the connection between hydrology and sort of ecological processes that result from it. So what this tells you, the blue hydrograph is 2011. We all know that was a big water year. And then this kind of orange one here is actually last year, 2022, when we had that big snowpack and some sustained flows that actually exceeded the I think they did a flushing flow last year, but the natural runoff kind of overwhelmed that. So typically the flushing flows are a little bit earlier. I think that's what these peaks represent. They happen in, mid to late May. So it's really when you get these natural kind of big water years that you get the good conditions for cottonwoods and willows in the river. So this is kind of a study that's in progress. The question is, can we influence our ability to regenerate new cottonwood and willow communities through flow management from Pelican Dam? I think the answer is probably, but it's already happening. And it's mostly driven by these kind of natural big water years. But I think we can probably take a closer look at what's happening and maybe refine it a little bit. But it's not just the water, it's also, I'll show you a slide later that kind of really underscores that it's also things that are going on with land management such as browse and have a big effect on it. So this is a point bar showing willows that are about 4 years old. I cut the stems and counted the rings. Doesn't mean the plants are 4 years old, it just means that the stems above the ground are 4 years old. They're very good at being sheared off by ice events, which I know you have on Madison, and then regrowing from the root systems. These are cottonwoods that were about 16 years old. So they date back to, maybe probably 2006 is about, I think 2006 was a big water year in a lot of rivers. And you can see how these are scoured by the ice events that you have in this lower part of the river. This is below Barney Bridge.
This is gorged right there.
What's that?
That area is gorged. Is that what you said?
I think so, yeah.
Yeah.
That's what it sure looks like. They were scoured by something. And then this is another willow stand kind of in the same location, all within these light blue areas that we were expecting to see that basically happening. So the question was, are we getting any kind of cottonwood and willow regeneration? The answer is yes. What's probably preventing it from turning into new cottonwood forests is all of the wildlife browse, the gorge, livestock grazing where you have private land in these areas. So it's more of a land use issue than it is a flow, ecological flow issue. And this is from another river where we're doing similar, I guess, experiments working with flow management. This is the Kootenai River below Libby Dam in Idaho near Bonner's Ferry. This is about 2 miles upstream from Bonner's Ferry. So this is an area where we did a project. We removed about 2 feet of sediment that had a lot of reed canary grass growing on it, exposed this kind of fine sand, which is abundant in that valley because it used to be a glacial, basically a glacial lake that filled in. So creating conditions, the right elevation to support new cottonwood growth. So we did that, and then we'd see cottonwoods start to grow every year, and then we'd come back the next year and they'd be gone. And it was because the deer were eating them. So we started to put up these fences, and you can see the difference when you protect an area from browse. And then eventually this whole side channel kind of passed the threshold, and even areas outside the fence grew up in cottonwoods. This project was built in 2012, I think. And about 2020, I started to see the full cottonwood forest come in. So there are techniques where you can, work with the flows, work with land management, and kind of use natural processes to produce restoration. You don't have to go plant every single thing. And these did all come in from seed, from natural seed. So to kind of sum up where we're at, next steps, Story Ditch floodplain and riverbank restoration 2023 project, side channel restoration 2024, and probably future years. First one that gets built in 2024 will be monitored and used as kind of a learning experience. I think there's also some thought of expanding the restoration planning to be more comprehensive, including aquatic habitat, river management, flow management, maybe some tributaries. Further looking at the flow management opportunities, kind of in the context I was just talking about. There's also some thought of doing projects below Earthquake Lake to reconnect some spawning gravels up there. And then it all works because of partnerships. So continuing to grow partnerships with BLM, Montana Fish, Wildlife and Parks, Northwest Energy, U.S. Forest Service, private landowners, and river users, resulting in good stewardship. And I think the Madison River Foundation, as I understand it, kind of views their role as helping to drive these partnerships, working of course with the CD and other folks. So anyway, that's all I have. Folks have any questions or thoughts? Yeah.
How far upstream from the town takeout or the town bridge does the goalies go?
I don't know. Yeah, I don't know the answer to that. I know there is a line somewhere.
Is it pretty far? Upstream from town?
I don't think it's that far upstream. I think it may, like, I think I've heard it gets out into the Odell Creek area.
To the where?
Odell Creek area, I think. Anyway, I don't really know that answer.
But I think you were talking about how deer and other animals often browse the roads and population kind of like big grow. Has that dynamic always been in place, or is that a recent overpopulation of deer, or how has that changed since kind of more human development?
Like, why are there even rows anywhere if deer are always eating them?
Yeah.
I think it's kind of a supply and demand thing. In a lot of, especially agricultural floodplains, deer are, especially white-tailed deer, are attracted to those areas where they didn't used to be a significant part of the population. So you have more deer, fewer woody plants, and it's just, they just get overwhelmed, and there's more demand for them than there is supply, so they get wiped out.
Also, can you talk a little bit more about, it was really interesting reading about how there used to be the layers of sedge and willow and then kind of conifer or deciduous tree. Can you talk a little bit more about how that farthest back layer of tree would have affected the ecosystem other than just providing wood for the river? Was that like an animal habitat, or how else did that impact?
So when we think about habitat, we often talk about vertical structure. So if you just have grasses and sedges, then you just have that one layer. You're going to have one type of ecosystem that supports a much smaller diversity of wildlife. And then if you add your shrub layer in, then you'll start getting your new tropical migrant birds. And other animals will use that because you have cover now. Cover for deer, cover for other larger animals. And then when you have forests, you're just kind of introducing that whole additional layer that brings in another, other guilds of bird species, different types of wildlife, different types of insects, a much more complex ecosystem. And then, of course, like you said, there's also the structural components of having wood that can, in many cases, is an important part of the ecosystem. All right. Any other questions or thoughts? Ideas for restoration projects?
I'm excited to see the side channel.
Yeah.
Today, after visiting, it's gonna be really interesting to follow.
I know, right?
Which side channel are you guys planning? Is it a different one from the one we toured a couple months ago on the deal that one.
Yeah. Yeah, you may remember there were some cultural issues which kind of overwhelmed that.
Okay. Where's this new one being planned?
Still being decided.
Okay, gotcha.
We looked at a couple, we looked at 3 other ones in that same general area.
Okay.
And there's one that people seem to really like a lot, so that made me, pursue it. And that would be neat because it includes some private land. Includes what? Some private land. With people who are, willing to participate as far as we do.
What stretch of the river is that? Is that above McAtee or?
Just above Mackenzie.
We're working on one on War Creek right now with Northwestern Energy and FWP all on private land. It's like a 4.4 mile stretch with 7 landowners from the town to the Valley Garden southern property boundary. And it's pretty neat. I was shocked when I heard this, but Mike Duncan with his GPS data actually found some trout that are still spawning in War Creek, which I was pretty surprised by. But yeah, everybody creates more spawning. More of that in there, and there's even been talk of down the line, once the project is complete, maybe doing some railing stopping where they got easy access to the state there and the U.S. Fish and Wildlife Service. So we're kicking that off this year. So all the pieces come together and pull it off. It'll be a big one there. They're in the planning phases for another one on the stretch from the southern boundary of Valley Garden Ranch all the way to Fletcher Channel, so that the connecting projects will achieve 10 miles restoration all the way from town to confluence.
Just confluence of that.
With the main stem of the Madison, it'll be directly down all the way from directly downstream from the town of Ennis to Fletcher Channel at the confluence with the main stem. So yeah, we're kicking off the first steps of that.
Who's with?
Oh, sorry, the Madison Conservation District. Yeah.
Is the Channels Ranch involved in that?
The Channels Ranch is familiar with the Channels Ranch.
Near the ranch, just before you get to the lake, there's a river downstream from Valley Garden. Take out from Valley Garden all the way down to the lake. You'll eventually run just as the channels 2 miles before the lake, roughly. The channels are very broad right there, and the ranch is on the east side.
Yeah, I don't know, they might be involved with the other piece with Valley Garden, but we're not involved with that.
Valley Garden Ranch, it's on both sides of